Okay guys, welcome to my new channel that I'm doing. This is going to be on space and a whole bunch of techie stuff. So in this video we're going to be talking about space, types of galaxies, star clusters, what types of star clusters, and I think one or two black holes. This is my video. First of all, what are star clusters? Star clusters are groups of stars that can range from 10,000 stars to all the way around 8 million stars, and sometimes even larger in rare occasions. The first type of star cluster is a globular star cluster. Globular star clusters are held together using gravitational fields from stars, galaxies, and, in some cases, even other star clusters. The second and final type of star cluster that I'm going to talk about are open star clusters. They are not held together using anything. They change around, shift, and pretty much get flung around by stray asteroids and a whole bunch of stuff like that we were talking about in class. That is an example of an open star cluster. Okay, now, galaxies. How many? What types? The number of galaxies in the universe is hard to tell because of the technology limitations that the human race has. The fact that there are sheer numbers of galaxies out there, like each of these individual little dots on here. This was taken from Earth, not even a telescope. And that is each an individual star. Most likely a galaxy. As it says here, about 100 to 200 billion galaxies. There are four types of galaxies: lenticular galaxies, spiral galaxies, elliptical galaxies, and irregular galaxies. These are both examples of them. First of all, elliptical galaxies. Elliptical galaxies are spheroid, or in simpler terms, they are oval shaped. They usually have smooth lighting as compared to spiral galaxies, which sometimes have sharp lighting. They are given names on how close or far away they are from being a perfect sphere or circle. The way they are measured is from E0 to E7. Unfortunately, since of our technology, we can only see 2 of the 3 dimensions that galaxies have, so we have to base it off of that. Elliptical galaxies are also not as famous as spiral galaxies. I'm guessing that's because we live in a spiral galaxy. But elliptical galaxies are much, much larger, and they can contain about 1 trillion stars. And they contain mainly population 2 stars. Population 2 stars are typically extremely old stars over 1 billion. Okay, now on to irregular galaxies. Irregular galaxies are galaxies that have no form, or they've collided with other galaxies, and they've been shifted with the gravity of other galaxies. So they've been distorted so much that they don't fit into any of the other 3 categories. That is an extremely weirdly shaped galaxy that I found. Should probably put it in here. Irregular galaxies are put into 2 specific categories: IRRI and IRRII. IRRI galaxies have an area called HII regions. HII regions are made up of hydrogen gas, while the other one, on the other hand, has massive dust clouds, so you can barely see any distinct stars. So this one right here would probably be an IRRI. That, on the other hand, would probably be an IRRI. Sad. Spiral galaxies. Galaxies that have 3 main parts: the bulge, disk, halo. The bulge is also known as the nuclear bulge. It is also found in the dead center of the galaxy. The disk is just outside, and it is the main frame of the galaxy that is composed of all the stars. And then there is the halo, which is globular star clusters. As I was saying earlier, they are held in place by gravitational pulls. And in this case, it is of this galaxy. Spiral galaxies are classified in 2 groups: barred and ordinary. Ordinary galaxies are classified by S and A, or S and S. While the barred galaxies are classified by SB. The classification, other than S, SA, SB, goes A, B, C, all the way through to Z, while A having the tightest arms and Z having the most extended arms. The difference between ordinary and barred is that ordinary, of course, just has normal arms, just like the Milky Way, as you can see right here, while barred has pretty much a giant bar of mass and material going through the dead center of the galaxy, which the arms go off of that. Now on to lenticular galaxies. Lenticular galaxies are defined because of their ill-defined arms, and they are also mixed up with spiral galaxies because there can be a bar through the lenticular ones as well. They can also be mixed up with elliptical galaxies because of the fact that they're composed almost entirely of population 2 stars. Lenticular galaxies are in between spiral and elliptical galaxies when it comes to classification and morphology. And lenticular galaxies are also much brighter than most spiral galaxies.